23rd second. We're coming down to the last seconds on the clock, and the 24th. What starts to happen here is the oscillations here are increasing so much. Again, as we look at this galaxy clock, we are seeing the creation of our own galaxy. We can look now for a moment at what the core and what a galaxy actually looks like, and we can see the same phenomena happening. The same creation is actually happening. So what's actually happening is if we take this spiral into an eternally smaller and smaller and smaller orbit, what starts to happen is the oscillations per second of the wave increase so dramatically as we get into smaller and smaller micro-orbits that basically go into the millions, the billions, and the trillions, and all the way to a Google. A number that is so high that as the oscillations get smaller and smaller and smaller, there's actually no end to how small we can go, because we can go into the micro-universe. And as we go into the micro-universe, the oscillations of the wave become so high that the frequency of gravity, the energy in the vortex, the gravity force space and time line is showing us that as it's curving and as it's oscillating faster and faster and faster, that mass, as it comes in contact with this force, starts to accelerate. Photons go from a lower frequency wave state into a higher frequency wave state. For example, in the radio spectrum, as we looked at the electromagnetic spectrum earlier, the lowest part of the EM spectrum that we know, waves are oscillating at around 1,000 times per second. By the time you get into visible or even radio frequency, you're at 1,000,000 times per second. A wave is oscillating 1,000,000 times per second. That means over a distance of 186,282 miles, if we had a wave that long and we coiled it, it would oscillate 1,000,000 times in the frequency of radio. In microwaves, you're oscillating 1,000,000,000 times per second. And by the time you get into infrared, you're at 1,000,000,000,000 times per second. So when we get into the visible light spectrum, we're operating and oscillating at numbers that are so high in frequency. So what's happening as this frequency increases is, again, the force of gravity becomes so strong that any mass that becomes in contact with that frequency, photons or even solid mass, the frequency of that mass becomes so high that the mass becomes, in essence, lighter. In other words, it doesn't have that sort of feeling of weight to it, the feeling of mass. So it starts to accelerate. So this is starting to tell us what's happening in a black hole in the center of our galaxy. If we look at a black hole, first of all, it appears black. And most scientists think that it's just a tremendous force of gravity in the center of the black hole. And they're right. But what this theory shows is there's something else happening in a black hole. We're seeing oscillations per second going so fast, and that matter, mass, photons, are actually starting to come in contact with this field. And at this point, which is known as the event horizon in a black hole, matter is accelerating beyond the speed of light. And if matter accelerates beyond the speed of light, and we view the universe, we take pictures with cameras, when we look at a black hole, you can't see anything because it's oscillating faster than the wavelengths with which we see light with our brains. So we get a void. A picture of a black hole shows it to be black because it's oscillating too fast. It's going beyond the speed of light, so therefore it just appears black. If really we had cameras and wavelengths in our brain capable of seeing into higher frequencies and energies, a black hole would actually be luminous. It would just be a greater increase of energy, according to this theory. So as we get smaller and smaller and smaller in the orbits, the oscillations per second start to go into numbers that the highest number ever counted is a Google. A number per second that we can't even imagine. So at that point, if we could make a spacecraft that could oscillate with energy vibrations anywhere near this point, we would see that spacecraft be capable of producing energies that could allow it to conquer the speeds of light. So what does all this have to do with the UFOs? What does this have to do with the UFOs in this investigation? Well, it wasn't going to be clear to me until a month later, after I had this discovery, that I actually took pictures of the waves that were pulsating off of the UFOs in the STS-75 tether incident. I actually slowed the video down frame by frame, and I took pictures off a TV monitor to actually look at the waves themselves. I really had no idea what I was going to find. But before we go to there, I'm going to explain a few more things about the gravity beyond light speed theory and how this model is not only showing us what's happening in our galaxy, but also is showing what's happening in our microuniverse. In theory, this is just a theory. It's a theory on paper. It would have to be demonstrated and proven to be correct. One experiment done by a physicist named Dr. Randall Mills at a company called Blacklight Power, if we go into the microuniverse, assuming that on my galaxy clock here, the distances I'm using, the size of this clock is about 6 million miles across, which is not actually that large in comparison to even our solar system. If this was Earth here and the Sun is 93 million miles away, we can see if this is 6 million miles, it's not that big of an amount of space to be having these orbits moving through. But assuming we're getting way into here, and this is the size of an atom, and this is the proton in the middle of the atom, and these orbits here are layers in which an electron orbits around the proton. The hydrogen atom has one proton and one electron. And we all know that hydrogen is a source of fuel and is a source of energy. Dr. Randall Mills took, using a chemical process, actually shortened the distance between an electron's orbit in a hydrogen atom. In other words, if an electron was orbiting here, he caused it to jump to, say, here. What would happen if we could change the orbit of an electron from here to the energy in a hydrogen atom? According to this theory, the answer is obvious. If the electron jumped from here to here, you would see an increase in the frequency of the oscillation of the electron around the proton. Here, if we go into an innermost wheel, if we move into a closer wheel to the center of the proton, you would see an increase in the oscillation of the electron around the proton, and therefore an increase of energy. Well, in Randall Mills' experiments, once he shortened the distance between the electron's orbit around the proton, that's exactly what happened. The hydrogen atoms started to produce more energy in the form of actual heat and in the form of actual energy waves. Although Randall Mills doesn't have this same explanation, when I applied his experiment to the galaxy clock, I saw that it fit in perfectly. So even on a micro level, in the micro universe, we can see the same thing happening. An increase in oscillations represents an increase in energy. So now I'm going to explain a little bit about going into this process of how electromagnetism increases as oscillations in electric fields increase. We're going to look at a little bit of a different diagram. The evidence of magnetism increasing as oscillations of photons, which are just electromagnetic waves, can be demonstrated in part by the properties of an electromagnet. If we take a conductor rod such as copper or steel, and we wrap windings of copper wire around the conductor and run an electric current through the wire, the conductor rod turns into a magnet. This is because as electromagnetism through the wire oscillates around a nucleus, the conductor rod, energy in the form of magnetism, gravity, is produced in the vortex. The energy in the form of magnetism produced is relative to the frequency with which the current oscillates through the wire around the conductor.